In this class, we will learn the basic logic, gates, in digital circuits, and its functions. Gate circuit is a logic circuit, composed of transistor switching elements. Because its working state is like a door, which is open or closed. Gate circuits are the basic units for implementing basic logical operations and compound logic operations. It has a wide range of applications. The logic here is easier to understand. The rule governing the relationship between the conditions of an event and its outcomes, which is the causal relationship. For example, such as the on-off of a switch, the presence or absence of a signal, the brightness of a light, we can use the numbers 1 and 0 to represent the logical state of an event. In digital circuits, the level of the voltage and circuits on-off can also be expressed by these two logical states. A gate circuit uses different logical laws to achieve logical control of the circuit. Next, we will learn the basic logic gate circuits. One is AND gate circuit. Let's learn the AND gate circuit first, the meaning of an AND. When all the conditions that determine an event are met, the result will occur. This causal relationship is called an AND. The logic and logic layer are shown in figure. A and B are two switches. F is a light bulb. Therefore, here, the on/off states of A and B are the conditions of logic, while the light on and off is the result of the logic. In this AND logic circuit, only when both switches A and B are closed, the light bulb F will light up. As long as one of the switches, the condition of being closed, is not satisfied, the light will not turn on. This is the logic symbol of an AND gate. The logic function expression is F equals A dot times B. The logic truth table is shown in the figure. It can be summarized as any 0 in gives a 0 out. All 1s in gives a 1 out. 2. OR gate circuit. Next, let's look at the OR gate circuit. The meaning of OR. As long as one of the conditions that determine a certain event is satisfied, the result will occur. Only when all conditions are not satisfied, the result will not occur. This causal relationship is called OR logic, logical addition. In the OR logic circuit, shown in the figure, for switches A and B, as long as one of the switches is closed, the light F will light up. When both switches A and B are open, the light F will not light up. This is the logic symbol of the OR circuit. The logic function expression is F equals A plus B. The logic truth table is shown in the figure. It can be summarized as any 1 in gives a 1 out. All 0s in gives a 0 out. 3. NOT gate circuit. When the condition for a certain event is not met, the result will definitely occur. But when the condition is met, the result does not occur. This causal relationship is called NAND logic and logic NAND. This is a non-logic circuit. When switch A is open, light F turns on. When switch A is closed, the light F will not light up. The logic symbol of the NOT gate is as follows. The logic function, expression F A. The non-logical truth table is shown in the figure. It can be summarized as C1, output 0, C0, output 1. We have learned an OR and NOT. 3 basic logic gate circuits. These 3 basic logic gate circuits can help us to achieve simple circuit control functions. It is also the basis for us to learn complex combinatorial logic circuits. Please think about it. If we combine basic logic gate circuits, what kind of logical relationships can be obtained?